Welcome to the Meltzone podcast. This is episode 45 from April 26th, 2021. Wow, that year number still feels weird. I'm Tom.
And I'm Stefan. And on today's the Meltzone episode, Meltzone podcast episode, sorry. We will be talking about weird printers, starting with a 3D printing simulation game called Speedcraft 3D. Really weird. Then a dynamic 3D printing platform which is basically consisting out of little pads that can move upwards in order to save on support material. And a Japanese 3D printing project where, a 3D printer is used to print on its platform a production line for sandwiches, cars, and other weird stuff. Really interesting to take a look at. And also some remarks on Thermorph, which is a cool concept where you print PLA and TPU on each other, and when you later put it into water, your flat part magically transforms into a 3D printed structure.
Nice. And as to less nice topics, the first one we have Creality's community firmware being sold as somebody else's own development. I guess that's what I'm taking away from the threads here. Is that legally okay? Is that morally okay? We'll take a look at that. And also patents. Again, it's a recurring topic, but this is the first time that we've actually seen patents being used the way that they're intended. SliceEngineering has made sure that the Dragon Hotend is taken off the market, which is a Hotend that is, let's say, heavily inspired by the Mosquito Hotend they're making. So yeah, pros and cons of patent, recurring topic, this time with actual, with something actually happening. And we close out with a question about the state of slices and why they're only supporting STL and not the more perfect formats like STEP and IGES. IGES. Anyways, IGES. Okay. But first, let's start with the weather. You're in your loft. I'm in the basement studio. It is sunny outside. And
do you even see that?
No, I have no windows in here. And the two windows that I do have, I've boarded over, so. Looks like sunshine, but it's actually all just studio lighting. You've got real sunshine though, right?
Yeah, I do. So if the weather goes bad outside, my face lighting won't be that good anymore.
Oh well.
For everyone who's watching.
Oh yeah, right. We are a podcast. I forgot. Yeah, so we just talked about like Stefan's already exhausted. We've already talked about so much stuff like the battery packs that I'm building, YouTube monetization changes, all that. I don't know if you guys are interested in all that behind the scenes stuff, but yeah, we always take this opportunity and we just chat about the stuff that's going on.
Yeah, our regular 3-week, 2-week, 4-week chat about things that are going on.
Yeah, I do enjoy that. My goal with the podcast, I don't know how you're seeing that, but my goal with the podcast was just, again, to have a format that was less formal, less produced, less, effort, more, just hang out, talk about stuff, and share it with the world, and that's working. And we didn't put that in the topics, but we passed 10,000 subscribers on YouTube.
Yeah.
We don't get a badge for that, do we?
Bronze play button for us.
Yeah, do I still have? I made that microscopic play button once.
Oh yes.
Like really nice one.
But you did that for your.
I did that for 100. Yeah,
because
that badge took, I don't know, another 80,000 subscribers to arrive. So yeah, we're popular, guys. But it's not just YouTube. It's also all the audio platforms, because this podcast again is available on YouTube with the video feed, but also just as an audio version on everywhere. We got asked if we were on Spotify the other day, but we are.
We are definitely. And I think the share between YouTube views and downloads, like just the audio version, is pretty similar. The stats on just like the podcast, the audio part, are really horrible compared, I guess, to what we are used to with YouTube.
Yeah, you don't get get information. You get number of downloads, and that's pretty much it.
We have passed 10,000 subscribers here on YouTube. Can you remember how many we basically just dragged into it by rebranding your live channel?
I think it was like 6,500 or something.
Okay.
However, many of those did leave, so I need to point that out. That many of them just did not stick around because, well, it's a totally different concept. But it was nice to have like some numbers to start with, even if they're not real. I don't know.
But again, I think we are. We can say that this has become a pretty popular format for us. It still takes more work than I thought in the beginning. And this is also, I guess, one of the reasons why this podcast is not as regular as it could be.
Yeah, because I mean, we need to find a time where we can just get together for 3 hours, basically.
Yeah.
But
Which is hard from time to time.
Yeah, we did make this. By the way, I know I just said I don't know how much you guys are interested in the behind the scenes, but we are going to try a different video transmitting service for Stefan, a different video chat service basically. So Stefan is hopefully not as blurry anymore in the future, but yeah, we've slimmed down the process of creating these podcasts from. We sent back 6 gigabytes of files for every episode, and then it's getting edited together. Now it's all into OBS. This is basically being recorded as a live stream. We could stream this, but yeah, then we have live chat and all that to worry about. But yeah, it's been the process of creating an episode has been compressed quite a bit.
Yeah. I just checked the YouTube stats, and we started with 3,600 subscribers.
Oh, so I thought there was more. Okay, so we did gain a significant amount of subscribers through the Meltzone, with the Meltzone.
Yeah.
So thank you all for that.
Thank you very much. That's pretty nice. Yeah. And we don't really have anything celebratory. What's the right word?
We aren't celebrities, or what's the...
Something we do as a celebration.
Oh, okay. It's a celebratory something.
Something. Well, we had a new logo, but that was still just right before we passed. I still really like it. I'm still kind of confused when I see that on Twitter, but I'm pretty happy with the results.
Yeah, absolutely. Yeah, and the thing with 10,000 on YouTube, like you said, it's a podcast. We've been over 10,000 like people who have subscribed to the podcast in all its forms for a while, and this is just like on one platform now. So, yeah. But yeah, let's actually make this a podcast and talk about stuff other than meta stuff about the podcast. Let's jump right into the topics, and this is the one that you put in there that is kind of weird.
It's kind of weird.
You called it a 3D printing simulator.
I called that a 3D printing simulator. So
exactly, that's the problem with it.
So every day we both receive a ton of emails from different sources, being it 3D printer manufacturers, filament manufacturers, or just weird stuff. And this was one that was still 3D printing related, but was in the weird category. So I called it 3D printing simulator. So I think it was like 2 months ago. Speed with a 3D as
Speed 3D.
So, Speed 3D Craft, Speedcraft, which are, I think, a manufacturer of metal 3D printers. they
would guess as much, yes.
basically had somebody develop a 3D printing simulator in, I think, the Unreal Engine, which I unfortunately haven't tried it out, because in order to download it, you need to, I don't know, if you just need to register with name and email address, or if there's even more to it. But you can download it for free on their website, and it looks like to be basically a survival game. You're stranded on an island with just a 3D printer, like a metal 3D printer.
Yeah, I don't know if the environments do anything for the game, to be honest, looking through this. So you can play in like, oh, there's even Autodesk Fusion in there? What? You get like 3 different play environments. One is like in the savannah, one's on a ship, and the other one looks just like darkness in the forest or something. And it kind of reminds me of like Raft, the game Raft or something. You pick up your resources, you feed them into a 3D printer, and then there's like test report, print test passed, material properties test passed, dimension test failed testing. Like, what? You have to feed the printer materials. I don't know if you have to craft like the aluminum bronze supply or what. Is there like a zombie horde that's approaching? I don't know.
I don't know. I think you maybe just need to get out of where you are. Fix your ship. I don't know. Build a car to get out of the desert. I don't even know where the electricity is coming from there. But yeah, unfortunately, I haven't tried it out. I should try it out, but since I have so little time to even play things that I really want to play, I don't know if I missed something, or if this would have been a waste of time. I tried to check it out right now, but I think there isn't any multiplayer mode. So.
Yeah. Well, I'm playing Satisfactory with a buddy right now, and I think that's a better crafting game than this.
Well, you don't know.
I don't know. Yeah, I mean they're selling it as or marketing as a training environment where people learn about 3D printing, but I don't know how much training people will get out of it. It is interesting. It is weird for sure.
Satisfactory looks a little better, but still, Speedcraft is also made in the, I think, Unreal Engine.
Yeah. I mean, Unreal Engine is awesome. Just the stuff you can do. Spee 3D is the company, and Spee 3D Craft is the game, and it is literally SPEE 3D. So it's like Spee 3D Craft, die Schlaue auszudrucken. Germans will get that reference, but yeah, I think it's nice that that's we're seeing experience, we're seeing like just weird stuff happening instead of just more the same. There are only so much cheap printers we can cover. So many cheap printers. I've just did the video on the Elegoo Neptune 2, and it's like, well, it's another Ender 3 that's marginally different than the actual Ender 3, and it's a bit better, but it's that gets boring, and it's just a breath of fresh air to see.
I think I have actually seen those guys. I think just as a correction, the company is called Speed or Spee 3D. And the game is called Speedcraft or Spee 3D Craft. I think I have seen them the last years at Formnext, and they are showing a metal 3D printer that is different to, I think, what most know what a metal 3D printer is, because I think they're using high velocity. So I think the process is called high speed cold spray deposition or something like that. So you take a material and accelerate those particles as fast as you can, and then just slam them on a surface, and they'll basically cold weld.
Right.
And this gives you the possibility to work with really interesting materials, and it might not be as complicated as having like an argon environment, an expensive laser, and things like that, because you basically have a Venturi nozzle with a bunch of high pressure gas, and then you slam particles on a surface.
It's basically a sandblasting setup just on steroids.
Exactly. But I think you might be kind of limited by the shapes that you can produce, because I don't think that bridges will work that well if you try to deposit material in free air.
It looks like it's a 5-axis process, though.
Yeah, it is.
So, as in bridging, like we just print sideways. So, yeah, well, they got covered in the podcast at least, so it did something.
Definitely. Yeah, if anyone is bored, try out P3D Craft.
Sorry for that. That was the trailer that I just played. The audio from that got recorded. Yeah, it looks like there's. Hold on. So I'm seeing Fusion 360, but it's like Fusion 360 screenshots that they've got as a like virtual environment that you can click through.
Well, wow. Of course, if you're stranded on an island, don't have any. Well, Fusion 360 is not working if you don't have internet access.
Right.
Ooh.
So I guess you got stranded with a Starlink dish and an emergency power generator and about 1,000 liters of fuel for that. And that happens.
But why then not just download your parts from Thingiverse? Why design them yourself?
True. Wow. Okay, I think we're done with this. We do have something that's actually useful today, and that is the dynamic build platforms. And this is still weird, but it's weird in a really innovative way. That's it's pretty logical when you think about it. So
yeah.
This is an article from Hackaday. And I guess dynamic build platforms that saves on support material, that you should have an image in your head of what this stuff looks like. But basically it is it's a build platform that's segmented into individual bits that look like they're like 6 centimeters wide, but 6 by 6 centimeter squares. And each of those squares can move up. So you start your print with everything flat, and then as your tool head moves up and you need a supported material, one of those columns comes up and you print support material just onto that column, and you save material. Which I think is, like, again, it is super logical and it is super smart to implement it that way.
Yeah. Me too. It's non-intuitive at first, but if you think about it, it's so logical. So instead of printing a big pillar of material, you just at some point raise up that piston and, well, print on top of it. It is, if you're doing it the first time, I guess mechanically a bit challenging, because if you have a print platform that is what do they say in the paper, but it looks like as if you have like 12 by 12 of those actuators. That's 144 linear actuators under your build platform, and also linear actuators in a way that you have, I don't know, positional feedback, or at least you need to have a way to position them very precisely.
I guess you could, if it's like a low pressure pneumatic system, you could just bump them against the nozzle and just use that as a hard stop. You know what I mean?
You could do that.
Yeah,
yeah, and then just have a brake that,
and then just stop it there. But pneumatics always has like a bit of spring load action to that, so as soon as you remove the nozzle, that's gonna pop out a bit further.
Yeah, but if you have
compensate for that.
But if you have a brake at your piston,
if you have a mechanical brake,
right? Yeah, a mechanical brake.
Yeah, you could do that.
You should have patented that. No. So yeah, if who actually made University of Southern California? Yeah, if you're listening, that's way easier.
But okay, so what they let me just cite the Hackaday article here. Before the print is made, the bed is prepared by inserting the appropriate length tubes in the correct squares. Then, during the print, a single motor pushes a platform up, and based on the height of the pin, that portion of the bed raises appropriately, then stops at the right height. So it sounds like they have not just your extension tubes already, I guess, cut to the correct size. But there is a single motor that moves around underneath the platform and just pushes it up. Is that, or is it? Is it an individual motor pad? Because it is quite challenging to control. What 144 individual columns. That is quite a bit of effort, but yeah, so by having those, the way they're doing it with the pins already at the roughly correct size or correct length, you're not going to have like super fine granular control over how high they raise. So, and you can see in the picture, it's a person with basically a handstand and the legs kind of in a V shape or a Y shape. And you can see the supports are at different granular levels, so it's not
discrete steps.
Yes, yeah, exactly. Thank you. At discrete steps, so you still need to build up a bit of support material. You don't get right up to that. So you have just pre-cut rods in the correct length. So it's again, this is we're already coming up with ways that you could do this differently or better, but this is the first time somebody's doing that, as far as I know. And that is already a pretty nice achievement there, because it does save on material and on print time. So job done. Job well done, actually.
Yeah. No, I find that really nice. And well, if you have flat overhangs, it also enables you to print them directly without any support, and you have not so nice looking down facing surfaces that were printed on the supports, because if they are flat, you can basically print them directly on the on the pins that go up.
But I thought Simplify 3D has supports that come up so nicely. But
only version 5.0.
Yeah, that's going to be so much better. But yeah, the thing is, if you print directly on those pillars that come up, you are limited to geometry that directly fits onto those pillars, because again, you have discrete heights that you can set these to. Yeah,
so there is a video linked to that or linked under that Hackaday article, and that actually looks like as if the movement of the pins is connected to the movement of the Z-axis of the printer. And they then just stop at some point because they have a discrete length, which makes it even simpler. So you don't have individual actuators. You just swap out the pins, and all the pins are going up during printing, and they just stop at some point.
Right. I thought they would. Yeah. So, of course, you can't have the pins already extended at the start of the print, because your tool is going to crash into those. That's the first thing you have to realize, because, printer tool heads have some sort of spatial extension. But you could leave them in the down position, and then when you get to the layer where you need them, you extend them in one go. But yeah, I guess you can also just move them up, and with them being at how would that work? Because the other ones keep moving up. They would need to be decoupled from whatever. I don't know. Maybe we can get in touch with one of the people that worked on that paper or on that concept. I guess this is super interesting stuff here.
It's nice to see.
It looks like it's one continuous motion from the bottom, but how would that work?
I hope it's not yet patented, because bought by Stratasys, because otherwise, this could be a concept I could realistically see being implemented on a machine where you, for example, do mass production of, or not really mass production, but if you print a specific part over and over again, because you would only need to swap out the pins once, and then you're ready to go and save a ton of material and print time.
Yeah, with the with the concept of using just fixed length rods for sure. Or even, it doesn't. This is one of those cases for where you have like customization through 3D printing, where you have your same base model, like I think Mini does that with like printed inserts for their car, where you can have your name on car parts, where the base shape of the part stays the same, but details change, like the labeling or the engraving, the printed engraving in a component. So the length of your supports would stay the same, but the actual geometry you print on those would marginally change. Is there an easier way to implement it? I don't think so. I don't think there's like, because you can't have a bed mold that comes up again because you're colliding. Yeah. Really fascinating concept.
It's a fascinating concept, and I think also challenging in a way that you still need to position them precisely, because otherwise your first layer won't stick. And I think if they basically, mechanically link the z-axis of the printer, well, it was a delta printer,
yeah, so there's no z-axis
linking the
per
z-axis
se.
Yeah.
I guess so. First layer adhesion, as in getting the height perfect, I don't think that's that much of a problem. You can just use a wide extrusion track, and that's kind of mostly self-level. Like if you're a millimeter off, it should still, I guess, kind of stick. If you just lay it on a really fat track, that should still work. But I guess it needs to be mechanically locked in place. Like it can't start wobbling around. That could go pretty wrong pretty quickly.
Cool. On, I guess, the topic of weird 3D printers.
Yeah, we've got a really weird episode today with unique stuff.
Yeah, weird, unique stuff. There was a team of researchers from the I need to pronounce that, Meiji University of Tokyo, and they basically printed a machine on a 3D printer with removable tool heads, and they used the print head of the printer later as a tool changer or tool pickup system that was then able to assemble a sandwich, or what else have they done?
Yeah, so the quick correction there, I guess. The tool head stays on the printer. The print head, the actual Hotend, stays on the printer. They're using a Creality, some Creality looking machine, but they've added a little box compartment next to the tool head. So the idea is the printer prints its own tools at first and then picks them up with the tool head, right? So it's like a little printed end effector or a little hook that they've got. They first print it onto the platform, then the tool head moves down and slides into that and picks up that tool. And then you have, an additional tool on your tool head that you can move around. So they're using that, basically they printed I don't know if they printed a knife and then cut some bread and
they did.
Pastrami. Did they? Okay, so I do remember that correctly. So basically they printed a jig onto the platform. It stays on the platform. Then you insert your bread and you insert your pastrami and your butter now, and the printer prints its tools to pick up the bread and to cut the bread and to assemble a sandwich, and it then gives you the sandwich in a dedicated printed exit slot, basically. So automated assembly, first of all, automated printing of tools for the job of then assembling stuff on the printer's tool plate, a tooled bed. What's it called?
Print bed.
On the print bed, in the printer's working envelope, basically. So that they have sandwiches, which does require external material input. But they've also done other stuff, like I think the Rabbit Factory, where they have different platforms that they print, or bunnies, I guess. They replicate faster. They've got a bunny printing platform that was first printed onto the bed, and then it prints a bunny onto that. It prints a bunny package, and it picks up the bunny, puts it into the package, closes that package, and then gives you the finished. I think it slides off a ramp or something. It gives you the finished packaged bunny, and at that point, you're your printing platform, your printing space that it printed its own stuff onto is now clear again, and it repeats the cycle. So the only thing you have to feed in is filament.
Yeah.
Or assembling like little toy cars with functioning wheels. So it prints the wheels, it prints the car frame in the center, it prints the wheels off to the sides, and then it lifts up a hinge that pushes those wheels into the car's frame. And the idea is, I guess, you print onto a jig that then releases your printed part again. It's fascinating to watch.
It's totally fascinating, and I would have totally expected that from a Japanese university, because
for sure.
It looks like origami. Is it practical at the moment? No, of course not, but I think it's just really mesmerizing to take a look at how that works. It looks like one of these Rubin Goldberg machines.
Rubin Goldberg machines, yeah.
Rubin.
It's. I mean, you're saying it's not practical, but I mean, it might be practical for some stuff, and maybe not this exact approach but the idea of just assembling parts on your printer's bed. That some stuff, where we need to print, I don't know, 1,000 that need some assembly, might be smart to do it with a printer that prints its own jig.
Yeah, and the way they basically integrated that tool mount onto their print head with different methods of picking up the tools is just really nice and well done. So the videos that they're showing, they have cuts in between, and I'm not 100% positive if everything works as straightforward as they show it, and might still need some manual interaction, but it's just a really nice proof of concept what you could do. And maybe someone has a nice idea to use that in a more practical manner.
Yeah, because I mean they do show like non-practical stuff here as well, like a 3D printed coffee mill, just entirely print in place grinder for coffee. Like I don't know, that doesn't sound like some coffee I'd want to have.
Yeah, but just the idea that you have a print in place coffee mill, and then you put the coffee inside, and then the print head is doing this rotational movement to basically move the handle of the print mill
of the coffee mill,
of the coffee mill, print mill of the coffee mill is just really nice. It's really nice to watch. Serial production, belt printer, removable bed printer, or some other mechanisms to get your prints off the plate. But this is just one level more, where you even assemble stuff on there.
Yeah. Let me just play the university's name here from Google Translator. Stefan, you're not going to hear that, but
Meiji University. Meiji University.
Is it Meiji?
So Google Translator is something like Meiji University. I guess the university is, but it's, we were close with the Meiji.
Cool concept.
Absolutely.
I want to see more. And maybe speaking of, I have the name right here, of origami 3D printing. I stumbled over a paper a while ago. I think that wasn't by a Japanese university.
Do you like literally have the printed paper?
I have the printed paper. Well, I have a page of printed patterns.
Okay.
Sorry. It is... I don't have the name anymore right here. Anyways, I can put that into the show notes. I have it somewhere. So they are doing 3D printed origami in a way that they combine layers of PLA and TPU. And after printing, put those parts into water. The water makes the PLA shrink in a specific direction. And the warping that's happening, also using the hinges that the TPU forms, creates your final shape in the end. So you print flat and then, with those integrated hinges. And also the interesting thing is you choose the printing orientation in a way that the warping happens in the direction you want it to be. And depending on the numbers of layers that you're using, depending on the print speed, because with a higher print speed, you have more internal stresses in the part that will release in the warm water. You can also adjust the amount your parts warp, and that is pretty nice. And I have already printed a couple of parts downstairs and wanted to make a video about that for quite a while, but never finished it so far. Really nice concept. Also just thought like one step ahead. Yeah.
That reminds me of those like self-assembling, not robots, but self-assembling assemblies, or the memory wire stuff you can get and pre-bend.
Yeah, it's a shape memory polymer
basically. And your shape memory comes from just the internal stresses that you have during printing.
Yeah.
Okay. Yeah. This is just something I keep realizing. We've got 3D printing. We've had 3D printing for basically 10 years now, I guess, available for, open source DIY stuff. And there's still so much that has not been explored. So many weird, unique concepts that, 95% of them are not going to be viable in the real world. But the other 5%, maybe they're just going to be awesome. They're going to turn out awesome, and they're going to enable us to do new things with this amazing tool set that we have these days.
Yeah. The concept I talked about is called Thermorph. So, like thermomorphing. Thermorph.
Yeah, gonna put that in the show notes.
And they even have a software tool in which you can basically simulate like the morphing process, and depending on your initial shape and final shape, it will calculate like the angles and the printing speed you need to use to get to the final shape. But
right,
I think the software is not available.
Okay, I was gonna say that it sounds like a very like mostly a software problem to solve. But yeah, the getting your parts pre-morphed in a way that you enter your final design or your final assembly that you want, and it spits out a print file that gets you there. That's gonna be pretty challenging. Kind of like you. Yeah, go ahead.
They have demonstrated it with like a rose that folds, or how did they call those parts?
So nothing that's like super precise.
It's nothing that's super precise or super complex, but in the end, it's just another idea maybe somebody else can pick up and just think one step more. Take a look at shape memory metals that are used, for example, for stents, where you have an initial shape, you deform the part, and then you insert it in somebody's body where you have a clogged blood vessel, and just like the temperature of your body morphs the part again into its initial shape. It gets bigger again, and therefore unblocks that blockage.
Hey,
this is one of the big applications for, I think, shape memory shape memory metals.
Yeah, we when you typically see those shape memory metals, it's like, well, it's a cool demonstration. You can bend the letter and it's you heat it up and it appears again. But yeah, there is an actual application with this sort of stuff. Oh god, did you see? Speaking of medical interventions, did you see Wren post about his one wheel accident?
Yeah.
Oh god, yeah. Wren, by the way, corridor crew. One wheel rider, VFX extraordinaire, and he ate it pretty hard apparently, and Well, exploded his collarbone. This one, the other side, his right collarbone, as far as I remember. It's like, well, the physical pain is one thing, but just that sinking feeling of, oh shit, this is gonna suck. That's the worst, because I've done that before, and it's just. So.
I do understand that. Since I started mountain biking quite a bit more again this year than I used to do it in the past, I now have a family. I'm also always thinking, okay, do I still, really take that trail, or do I just basically take the good roads down the hill? Is it really worth the fun, breaking your bones afterwards, or even worse? But
I mean, mountain biking is still relatively safe, and that's coming from someone who has like 2 major injuries still that he got on the bike. But mountain biking, I think, is just so much safer than being out on the road on an actual motorbike. Like you mess up on a motorbike, you're dead, or you end up in a wheelchair or something. On a mountain bike, I mean, what I've done, I've snapped a tendon in my shoulder, and I've that wasn't technically on the bike, but I've rear-ended a car and split my upper lip open, and this tooth is fake now. But like you're not gonna. It sucks if you mess up on a bike, but you're gonna be mostly fine after that. So I mean, mountain biking still is something that I think is fine. It's fun and it's fine still. So
yeah,
you could do much worse.
It could do much worse. Have you ever tried one of those one wheel, electric skateboards?
By the way, before I miss it, well, Wren, hope you get well soon. You know, our thoughts and prayers are with you, and not that they're going to do much, but yeah. Anyways, fingers crossed, Wren. Anyways, I have ever been on a one wheel or on a boosted board? No, because they're basically illegal here, and I've not gotten the chance to ride one where they are legal, are not legal where they are legal. So, I think best I've done is a hoverboard. I've not been very successful in that.
Aren't those electric skateboards now legal for a year or 2 here in Germany?
What?
I think they're legal now, at least to up to 25 kilometers. I think this, but don't quote me on that. I think this was basically hand in hand with all of those electric scooters.
But was that, what was it, Lenkstangenlose something?
Or something, yeah, you could be right there.
As far as I know, it's only electric scooters.
Okay. Yeah, because you also need to have the lights and...
Yeah, well, I guess that the point why scooters are legal and the boards are not is because you have something to hold on to. Two dudes Googling, I know that's... Lenkstangenlose something.
So, handlebar-less vehicle.
Elektro-Kleinstfahrzeuge aussuchtes.
I think it's not legal now. It's not legal yet.
So there were plans to allow those up to 12 kilometers an hour.
Okay. You can basically walk faster.
Yeah, and they were supposed to be legal basically as you count as a motorized pedestrian, so you drive on the sidewalk and not in the bike lane, and not on the road. So I don't think they're legal.
I have tried out one of those one wheel skateboards. How are they called? Uni.
What do you mean? Just the one wheel? They call it one wheel.
Yeah.
Self-balancing
big.
Sing.
Did he actually fall from one of those where you have this single go-kart wheel in the middle?
Yes.
And then just... Okay.
Yeah, that's the typical one wheel.
Yeah, I tried out one of them when I was, I think 4 or 5 years back in Upper New York State in one of this skateboard shop. It was really nice. I really enjoy that. I've been snowboarding and wakeboarding for 20 years, so this was really natural feeling. But yeah, they're pretty expensive.
They've compared to a booster board, they're not that crazy. And the cool thing is because they have such a large tire, they're not that dependent on the road you ride on. Like you can take them over gravel, you can take them over like bumpy tarmac. That all works. But the thing is, of course, they are self-balancing. They do depend on having spare torque basically to lift the nose up, and then they're regulated like an inverse pendulum basically. And what happened with Wren is was going top speed, and it ran out of steam. It ran out of torque to balance him. So nosedive, thing just grinds against the floor, stops you. You fly off. You have no chance of walking that off because it was like 20 something miles an hour, I think. So
that's pretty fast.
They go at quite a pace. Yeah. I don't know if he still does it, but he was commuting to work on that basically.
If you're so used to it, and if you know that it's usually reliable, I guess after a while you're not really prepared anymore for something bad happening.
Yeah, you're not in that heightened state of attention basically anymore. And that's what he said was what got him is, he knew the limits of the board, he knew the limits of what he could do and what he was supposed to do in it, and he ignored them and was like, oh, this is going to be, just went about his riding and stopped paying attention, and that's when it gets you.
Yep. So hope he's getting well soon.
Yeah.
I would still be really tempted to get one of those, but for me it's a useless piece of equipment. I bought my e-bike this year, so I basically bought myself the electric commuting toy.
Yeah. And in Germany it's like, well, you can drive or ride anything you want as long as it's a car or a bike. We'll accept those two, but yeah, buy a car.
No.
Oh well. But let's get back to 3D printing topics. And how do I don't have a segue for this. Sorry. Creality firmware and community firmware, and someone branding what is supposedly the community's developed firmware for the CR6 or the CR6 SE as their own firmware, not just selling it off as their own development, but actually monetizing it. So this has been something that's been discussed on Twitter with Nick Wilson over on, is this Facebook? Yeah, it looks like Facebook. Basically sharing his own Creality CR6 SE firmware and link to Patreon and going, hey, support me on Patreon to get this firmware. And, there's a calculator with it that does some e-steps and all that. And the alleged crime he was committing was that he was taking the community firmware and selling it as his own development. Now, there's basically two layers to this. First of all, well, three, I guess. First of all, is it really the community firmware? I have not verified that. Apparently, the allegation is that it is. Then, is it legal to do that? Is it legal to sell an open source software as your own and to make money off it? And is it morally okay? So, what's your input on that, Stefan? I guess
not a lawyer. You know way more about the open source, Creative Commons, whatever.
Okay.
I think basically the only thing that I can say, I think it's morally not okay. If you take the work of somebody else or even the community and make money out of that and, well, selling that to other people. If you are allowed to do that, I am not sure.
Okay. So yeah, the more.
And are you selling it if you have this as a patron tier?
Technically,
is
you
this
are
selling something.
Technically, it is a reward for giving. It's a transaction happening, right? There is a price set, and there are goods that are rewarded for paying that price. So I guess technically it's a business transaction, but also violating the license. I guess that was the other part, because apparently this wasn't exactly released as open source, but just as compiled files. So that's shady. But like morally, we keep seeing this over and over, that open source projects are put into, even if they're just put into another product and then that product is being sold. Like, I don't know, routers. They all run some I don't know if it's Linux, but they all run open source software basically on them. And then you're paying for that software through the price of that device that you're buying. Typically not just buying. Well, who is it? It's not Squarespace. It's Weebly. One of the web hosters is basically selling you WordPress, a skinned version of WordPress, more or less. But yeah, we keep seeing that, and legally, that's okay. So let's assume this is, I don't know, some sort of Marlin firmware. I don't know what it is exactly, but let's just say it's Marlin. Marlin is GPL. GPL allows you to charge money for the software, even if it's it's open source software. But there's no terms in there that it needs to be free of charge. All you need to do is you need to provide the source code of whatever you're distributing. I don't think you need to acknowledge whoever it's taken from, but I'm not certain about that. So legally, as long as the source code's provided, or if it's, I don't know, some self-developed firmware that's his own work, that's okay. But as long as the source code provided, he can sell as much as he wants. No problems there. Morally,
well, yeah. Well, and in the end, you could also say that somebody is providing a service in a way that you don't have to be member of a certain forum or need to know how to compile your software, firmware. That way that he basically provides a precompiled hex file that you can just, with manual and additional E-step calibration stuff, what you can use to simply upgrade the firmware on the printer. And you could also say he might be providing that as a service. Because I know that many are not comfortable or even capable of, in the old days, the Arduino IDE, nowadays the how's it called?
Visual Studio Code?
Visual Studio. I gotta be totally honest. In the beginning, it was also for me a challenge to download anything in there to compile my Marlin form code, my Marlin firmware. So in the end, this could be an argument. Yeah. Morally, okay, something different, but yeah, why not?
Yep.
Sorry.
So, I mean, it is what it is. It's hard times because we've not really, at least from what I remember, my generation, we've not had these big discussions of, hey, what can you do with free software? Like, where's the limit? The early days of software, like, it was all, hey, you have a floppy and I'm going to share that software with you. Nowadays, my generation has grown up on, well, you have Windows, you have Word, you buy those, and you don't really deal with source code. This is like a lot of people's first contact with open source and everything that's attached to it. Yeah. So I don't know if I don't know if this is the community firmware or not, but legally I don't see that much wrong with it. It's just morally, like I keep saying, I would rather see people contributing to one big project where everyone profits instead of spreading out into like individual bits where like this version has these changes and this one has these improvements. No, if everyone can use that, we're all better off.
But sometimes it's just hard to even find a point where to start with. And it was kind of similar for me when I started using the Duet boards more. The Duet boards are great, RepRap firmware, I really enjoy using it, but it took me quite a while to figure out how everything works for a certain machine. And even though all of that stuff is available for free, I could definitely see somebody make a business model out of providing configurations for printers and things like that in an easy, accessible way, where even somebody who is not that keen with electronics or with computers or hardware and just wants to use a printer as a tool for manufacturing jigs or for art projects or things like that, just to have somewhere where you can easily go, have checked firmware versions, configuration files to put on their machines.
Right. My understanding is that the community firmwares are already mostly doing that. Like, I'm not sure if every release is like that thoroughly vetted, but that's like if it's just about I don't want to compile this myself, I'm pretty sure that you can get the community versions as a pre-compiled version as well.
Yeah.
So,
but you need to find them, and for this printer you need to go in that Facebook group, and the next one is available only on Discord, and I find it kind of hard, maybe because I'm dealing with kind of a lot of different machines, but I can totally understand that this might be confusing from time to time.
Right. Yeah, and at the end of the day, like if there is a customer willing to buy it, like, you're succeeding, at least as a business. You're doing something right. So sticking with the topic of is this wrong or right, and are you succeeding? We now have what basically everyone was expecting. The SliceEngineering Hotends, the mosquitoes, are patented. And there's now been the first case where that patent has been used in the way that the patent is intended. And that is to make sure there is no competition that uses that patented approach. In this case, it's been the Dragon Hotend that's been taken off the market by Fetus 3D, I guess they're called.
Yeah. So the thing that is patented about the Mosquito Hotend is the way the heater block is mechanically linked to the heatsink.
Yes.
But still thermally isolated.
Yeah. Let me grab my Mosquito Hotends. Right there.
Plural.
Keep talking.
Yeah, so the thing is, I think I've seen the Dragon Hotend 2 or 3 years back, the first time on Form Next, where there were like really like big prints of those Hotends, and they basically looked like a straight copy of the SliceEngineering Mosquito, just with a differently shaped heatsink. And for the last years, SliceEngineering somehow, didn't do anything against that, but it just seems that they have now finally stepped in, and they're trying to stop the sale of that Hotend. And so I have got messages from people that try to order it from Triangle Labs on AliExpress. We can also now see it on 3DJ that the Dragon Hotend is not available anymore. And I'm quite interested to see how that's going to turn out. For once, the Mosquito Hotends, they are pretty expensive. I think just the Hotend with a heater block, but without a nozzle, without any electronics, is $180.
Yep. The
Dragon Hotend also was not cheap, but you could get like a fully working Hotend for around $60-$70.
I don't know exactly how much those are.
Yeah, just I think something in that ballpark. So I could totally understand why people said, okay, yeah, instead of buying like the genuine part, why not buy this one if it basically performs the same?
Yeah.
The big elephant in the room is, I think Slice Engineering, they are in the right that they are defending their patent, but should they have done it in a, well, community of open source, of like open source machines where this Hotend is used? Is this necessary for them to run their business? Or should they do it like in a similar way as E3D does it, that they are kind of fine with copies of their part?
Right. Okay, so before I weigh in, I need to add I might be biased on this. I've worked with Slice Engineering and with sponsorships on the channel before, specifically regarding the mosquitoes, and I'm currently talking to them about an upcoming sponsorship for a 3D printer build where their Hotend would fit in. So I might be biased here. Just want to put that out there.
Yeah, it's the same for me.
Okay. So we're both biased here. Now
we're both biased.
So I don't like patents on anything, on 3D printing, on patents. It's just 20 years is just too long. That's my problem with them.
Yeah.
What was I going to say? I see the point of patenting this exact assembly using the is it hypodermic needles, basically? That's what they're using for the thin stainless, or the same stock material for the thin stainless steel.
Very thin wall stainless steel tubes.
Exactly. That took a lot of time to get right. I was also involved in pre-testing these before they were even out on the market. So again, I'm biased, but there's been quite a bit of engineering going into this. Kind of the same with E3D. E3D basically pioneered the entire all-metal Hotend market, but this to me feels more like there's been effort put into this and something that's patent-worthy. I've seen patents in the 3D printing world that are just so blatantly obvious for stuff that is like, again, that's obvious. It's just patents for patent's sake. Even knowing that they're not going to be defensible if it comes, if it's actually challenged in court. Stuff like this probably is going to be defensible. But it's not to say that this is, the thing is you can work around this, right? You don't have to use the tubing for the mechanical support as well, because this is one center section of tubing. I guess on this one you can see it better. One center section of tubing that's guiding the filament, 4 pieces of tubing on the outside with a separate thermal path, and then 2 screws that tie it all together. You could easily replace that tubing with screws, basically get the same performance, and you've got an Ender 3 Hotend. Because those, have separate mechanical support versus the center tubing. So this isn't like stopping you from making a functionally equivalent Hotend. You have to work around it. Again, it's a patent. I don't like patents. I don't know. I wish they weren't patented. But hey, legally, they're in the clear. They've patented something that is unique, and as far as I know, has not been done before. Though I have not scraped the RepRap forums, and usually when you really go in there, the concept has been discussed before the stuff has been patented. But legally, I think they are in the clear, more or less. And let's be honest, did you expect them to not defend their patents? That's why you get a patent in the first place. And then when there's someone like Fetus with the Dragon Hotends that literally just copies it, or copies that patented approach, of course they're going to defend it. So, yeah,
well,
go ahead.
Of course, yeah, you spend money for engineering, for development, you spend money on the patent itself. You need to spend money to renew your patent every year, I guess. So why have a patent if you don't defend it? I think in the end, and this is something that is really hard, it's a business decision, because I find it very hard to survive as a pure open source. I'm giving all of my development away for free. It's working for some, Prusa. It's still working for E3D. But if you are a small company and have a really good idea, and this is an idea that can be easily copied, I think it's hard for you to keep running that business if you basically know that a couple of weeks later you get the same part for a quarter of the price from AliExpress. Why should somebody buy your product? And in that way, I find it a feasible decision to patent that solution, because otherwise you might not have spent the development money in the first place.
That's the usual argument for patents. Yeah, not just in 3D printing, but everywhere, basically.
Yeah. The thing is, 20 years is definitely too long. I could totally understand if something like that would be just purely available for the company for 2, 3, 4, 5 years, but in the world we live in today, 20 years is way too long. And also maybe on that note, it is kind of contrary to what like the whole 3D printing, or at least non-commercial 3D printing industry is built upon. And all the 3D printers we use nowadays are based on the RepRap project, and everything was free there, and information was shared freely, and ideas were shared freely. So I can totally understand if somebody says, why now put again patents into the mix that hinders development of the technology for the future and makes it less easily accessible.
Yeah. I guess to pick up on the Prusa and E3D are open source and it's working for them. I see two, specifically for both of them. I see a couple of reasons why it works for them and why it doesn't really work for others. For E3D and Prusa, they were really early to the game. Prusa was pretty late with commercializing the printer building side of things, but E3D, when they started making the V4, that was like one of 3 hot-end options that you could buy. One of 3 options that was commercially available that you could just buy and put into your printer. They were one of the first ones to make that and to make it to a good quality standard. That even today they have a reputation. People know I'm going to buy E3D. I'm going to get something that is repeatable, that is going to work. So that is still something that E3D is profiting off today, because they still make reliable, repeatable hot-ends. Whereas the clones, they take shortcuts and they don't work that well. A lot of the times. Yeah. With Prusa, the same thing. Like, they were really early to the game, but also, like, Prusa is just from the manufacturing standpoint, the Czech Republic is like halfway between German, US wage levels and China. Like, they can produce the printers for so much less than we in Germany or someone in the US could produce the same machine, the very same machine, everything identical. Just by the fact that they're in the Czech Republic, it's already giving them such a big economic advantage, which is why compared to other European American printers, they provide more value. Made in the US or made in Germany printers, made in Czech Republic is just going to give you more bang for the buck. And that is, I think, pretty much the only reason why they can survive against like the flood of Chinese printers that we're seeing, because those are getting good. Those are really cheap. But just the fact that Prusa can pour more effort into their printers and figure out all the details, that's what's allowing them to survive. And yeah, when you don't have that advantage of either being in a, well, Eastern European, well, Czech Republic is like right on the border, right? In a lower wage country where you just save money on wages and on people, basically, if you don't have that advantage, and if you don't have the advantage of having built up a reputation and you know, being a known brand to people, like, it's going to be hard to share everything. Yeah, I see that. Again, I would prefer if people shared everything, but there's just a reality that it doesn't work for everyone. It's not good for the community that we're seeing patents. It's not good for 3D printing as a whole. Yeah.
But in some cases, well, companies spend the money on development and develop things we would not have otherwise. If there's the possibility to patent them, or that they at least have the right to use what they have developed for a while and make money out of it, from it, and basically make the money that they spent beforehand during development.
Yep.
So in the end, I guess we have the option either, have everything for free, but development might be slower.
We've had Ender 3s for 5 years now.
Yeah.
Yeah, so
I don't know.
I more strongly disagree with stuff being patented when there's not a huge amount of development being put into it. When it's something that is more obvious. But yeah, so I guess question to you guys listening or watching, are you going to think less of us if we keep working with Slice Engineering and promoting their mosquito hotends on the channel? Okay. Specifically, I'm talking to Slice Engineering about sponsoring a Voron build. Right, I'm going to build a Voron 2.4.
How dare you?
Well, 2.4 is like at least 1.4 more than a no.
It's
2.4. Well, you've got the 0. Oh, it's 2.4 more than the 0.
It's infinity more than mine.
Yeah. I thought I needed to get into the game. And I'm going to talk to Dan Wednesday. So let us know if that's gonna be something that you're that's gonna make us look bad. You're promoting this patented product that's taking stuff off the market.
Yeah, I think many were for that reason unhappy because they have the impression, and of course, that's what it boils down to, that Slice Engineering is now taking away the way less expensive but very good Dragon Hotend. Because the mosquito Hotend and especially the Dragon, it looks still more similar to a V6, just like an evolution of a V6 due to the connection of the heatsink to the heater block. So they had the impression, and they basically want others to step in because Slice Engineering is taking that possibility away again, or is taking that possibility away because it's more than $200 to get a mosquito Hotend in comparison to 50, 60, $70 for a Dragon Hotend. So let us know.
Tough. Yeah.
It's tough. Yeah. I don't know. In the end, it's a business decision. And I can understand it in one way. I can also understand it in the other way. I'm really undecided.
Yeah. Again, I would prefer if you have a competitive advantage by just being able to make a better product. Say a Mera. You just figure that thing out to the end. You figure out manufacturing. You make sure that you can manufacture it at cost, and you have a product that is just better than the competition. Is that something you're going to be able to protect in the long run and to keep economically viable?
This is the interesting thing, and I also already thought about that. I think the only way nowadays you can get around still making money out of an open source project or product that you develop is that you put something into the mix that is not that easy to copy. And for the Hemera, it's the really nice custom motors. The nice stepper motors. It's the die-cast cover that they have. For the Prusa Mini, it's basically the heatsink. I guess, which is not a part that you can buy everywhere. Well, I think they had a custom extrusion made for that.
Right. The thing with Prusa printers is like it's the ecosystem. It's the fact that
it's also the ecosystem,
is great,
but
that the software is great, that's manuals, that all that you'd have to replicate all of that to get to the same level of Prusa. The hardware isn't anything special, to be honest.
Well, but the thing is, if everything is open source, I can sell my 100% copy of a Prusa Mini and also give them Prusa Slicer as a software and just tell them, okay, use the Prusa Mini preset, and there you have your ecosystem. And I think one of the reasons what at least makes it a little bit harder to copy it is to have more custom parts on the machine that are functionally relevant, and you can't easily replace them. Even though, you could just put a V6 on the Mini, and therefore still have, at least for a bit, your competitive advantage. For the Hemera, it's very interesting because I think there's not a straight copy of the Hemera available, but there's a scaled down version with, I think, a NEMA 14, but still die-cast housing. It's called, I don't know how that is.
Do you mean the Orbiter?
I think it's the Orbiter.
No,
it's not the Orbiter.
What's the aluminum extrusion guys?
LDO?
Yeah. Yeah, that they make, as far as I know, they make the Orbiter, which is not, I mean, it's more like a Bondtech BMG, basically, which is kind of like but you're talking something that's actually integrated with heatsink and all that.
Yes, just give me 1 second. It is called the BQ H2.
Okay, then that's...
It looks like a just tiny version of a Hemera. Where I think they did a good job, because one of the downsides of the Hemera is that it's quite heavy. And you might ask yourself, is that big stepper motor necessary if you have a gear reduction of 1 to 3 or 1 to whatever?
Yeah.
And they basically kind of improved on it and made a small version out of it. Also good. So not a bland copy, but taking that idea and just taking it one step further.
Yep. I guess at the end of the day, what it comes down to is, it's not just a hobby project anymore. I think me and a lot of other people, we've started 3D printing so early that we know, you could ring up Knobhead and he'd send you a set of Metal 90 parts, printed Metal 90 parts, because he didn't have a printer to start with yet. That's that sort of spirit of, hey, I'm just going to design something because I'm interested in it and because I want to share it with the world. That's not something that's going to be viable in the long run. At some point, especially when like the industry, because it isn't just a hobby anymore, 3D printing is an industry. If the industry wants to scale, like, you are going to have to bring in companies that are in it for the profit and not in it for just, hey, I'm interested in it and I want to provide the community with good parts. No. And every business has the core purpose of turning a profit somehow. And one of the ways of protecting your investment and turning a profit is, you need to protect your IP with stuff like a patent. So it's I guess it's a side effect of just where 3D printing is right now.
A weird in between.
Yeah.
All right. Shall we leave it right here?
Yeah, that would be another huge topic that we've got in our schedule. But I think that's going to be something for the next one. Let's do some questions.
Shall we just at least for a second talk about at least one question?
Sure.
Yeah. So, MG Berberich is asking basically, why are slicers still not reading like step or IGES files, and why are we still held back by triangulated formats?
Because
would we have advantages if we would directly slice from step or IGES files?
Yes, we would have advantages for sure. I mean, one of them that comes up is just smooth curves. STL doesn't have smooth curves. STL only has triangles. Something like step or IGES would have the option of corners, rounded surfaces that are not faceted into individual bits. In practice, though, STL is good enough, and I think that's why none of the like more perfect formats are really being adopted. STL just it compared to the resolution of the nozzle itself, the motion system, the imprecision of squirting down a molten blob of filament. Between all those things, if you export a high-res STL, you're not going to see any difference to a perfect geometry file like a step file. Even though that they would be better.
In the old days, this was still a problem because like slicers 5-6 years ago, if you would load a highly complex, smooth, bionic part that you want to print, slicing would have taken ages. With computing power, I wouldn't even say that it's computing power, but with optimized slicing algorithms, slicing is so fast that it is way easier in terms of computations in the background to just load a higher res part into your slicer and use that to generate your decode. And the resolution of the printer is usually not high enough that you would see the facets anymore. I think just like, I would say like, the last couple of years, 3D printers have become so good that sometimes you start seeing again facets on parts where that were, I think, beforehand smoothed out. There is maybe where this comes into play again. I think Fusion 360 now supports G2 and G3 if you slice your parts in Fusion 360.
Oh, okay. So G3 is, for those of you who don't know, is the curve in G-code where you can run a perfect circle. Because if you slice from an STL, theoretically, your G-code moves are just, linear moves as well. So every corner is going to be segmented into little linear moving bits as well. And if you have a perfect curve in your model and you slice in a program like Fusion 360 that gets the full perfect model with smooth curves, it can export those as curves into the G-code as well. And the printer then interpolates that into step of motion. Which, I mean, it works for circular motion. Yeah, it works for circular moves, but those are, unless it's, you're just printing a block with rounded corners, those are fairly rare, especially in organic stuff.
Yeah. I think, and I have seen that again and again, where this could become important again. Of course, you can slice your parts with a smaller you can slice parts with higher and higher resolution as much as you like. I have noticed it again and again that if your part resolution is too high, some mainboards are not capable anymore to basically digest the step commands or the G-code commands.
Used to be a much bigger problem when USB serial connection was still the standard and you had a laptop next to your computer and that was just continuously feeding G-code. It still is a problem with Octoprint because that's using the exact same approach unless you're writing to a SD card, which is super slow, but anyways. modern slices have a resolution setting that you can set to, I don't know, 0.1 of a millimeter if you need to. So that automatically merges segments that are shorter than that. And that basically adaptively decreases the resolution to something that your boards can handle. With boards, with 32-bit boards especially, that make use of a proper SD card interface and not just not SDIO. SPI is the other mode that SD cards support. When they're using SDIO, like and it's a 32-bit board, there are no real bottlenecks anymore. So yeah, with especially 32-bit boards, you don't have to worry about it really. So of course file size is going to be bigger. Just the geometry file size, an STL with exported at high resolution is going to be bigger than the step that has infinitely good resolution in theory. But again, we have, I don't know, we've got 2 terabyte SSDs. Is it really?
Just downloaded the latest update for Microsoft Flight Simulator and it was 50 gigabytes.
Yeah.
One thing that has also popped up in my comments, and I even tried that out a bunch of times in the past, is the Octoprint plugin called Arc Welder, which basically takes the G-code or the linear G-code commands and tries to fit arcs in there in order to have less basically G-code commands that need to be sent to the main board, and you end up with kind of smooth curves in the end. It helps if your setup is really bad. It can help, but I don't know. You have in the beginning but you add specific errors again, because also like converting a faceted part again to a round part will be in some places good, but you could also like lose details with that.
Yeah, you definitely lose precision in either case, because the faceted model is already the best effort of your CAD program to export it, and then you're processing that again. Skyforge actually, I think, supported that as well at some point.
Okay.
But yeah, talking about processing time, I still remember like slicing a basic frame piece for the salesman, and that took 25 minutes on a dual-core laptop. And then it took like another 10 minutes for the 3D preview to load, which looked horrible. So yeah, just to put that into perspective, like processing times in slicers have gotten so much better.
I still remember the first 3D. I had a Python 3D toolpath generator for my CNC router that I built, I think 7 years back, and just really slicing a very coarse half sphere took me half an hour. Just for really, really simple print moves. So it's crazy how far we have gotten. So in the end, yeah, of course, we would have advantages when using STEP and IGES, but just processing triangles for slicing is so easy because the math is so easy to slice a plane with a triangle and get a line from that, and then you connect all of those lines. Somebody who just finishes school is basically able to do that. If you're going into processing step files and then generating toolpaths out of that, it gets complicated. It gets way more complicated.
But Berberic is saying here as well, there are open source kernel libraries out there, like Open Cascade he's mentioning. I guess those would do that for you. But then again, the question is, how fast would they be about it?
Yeah. Okay. Yeah.
Yeah. It's good enough, and everything supports it. It's it's on the one hand, it's nice to have everything in 3D printing being kind of good enough and working for the job that it's doing. But on the other hand, I wish there would be more experimentation and more momentum to develop and improve things. but it is how it is.
One thing, and this doesn't really like affect slicing, where I really see where step files or IGES files would have a great advantage. Today I was looking for an enclosure for this 128/64 display for my Do-It Prusa. And yeah, I wanted to edit the geometry that I found on Thingiverse. But basically all of them just had the STL file uploaded. So I had basically the possibility to design it from scratch, to mix in Fusion 360 geometry and triangulated files, which is a pain and also not the right software for that.
But it does do it.
So yeah, it does do it, yeah. So I would see an advantage in the way that how models are shared nowadays. Having everything as a step file would make like just the remixability of projects way more straightforward and way easier.
Yeah, or even sharing source files, because if you're doing Fusion 360 source files, or designing in that, or in other software too, usually you can import those into, you can export SolidWorks files into pretty much everything. So that would help, because then you don't just get the perfect geometry that you can draw onto and pull references from, but you directly get the features. So if you have some hole size, you can just go into the feature, make the hole smaller, bigger, put it in a different spot. That's it. That would be perfect. Yeah. So am I sharing source files? I think I should start doing that more. I just started doing more disclosures. I'm working on being a better YouTuber dude. One step at a time.
One step at a time, indeed. But yeah, I don't think that we will see step or IGES slicing in the near future.
And if we see it, I think the first implementations of that are just going to be, well, here's the geometry kernel. It first exports it or converts it to an STL, and then the slicer works with that through its regular toolpath.
Most we were already almost finished. Most NC software, or a lot of NC software where you do like path planning for milling machines, they use the same approach. They are not doing the toolpath planning on, at least for the 3D commands, on the real geometry, but they will convert that geometry into an STL and do the 3D paths on exactly that STL geometry, because it's way easier.
Yeah. So yeah, that's just the way that the software works. Okay. I still need to get a better chair for these podcast recordings. I'm still sitting on the bar stool, and my back's starting to hurt. Yeah, I think we've nailed this one again.
Thanks for your time, Tom. Thanks for your time, listeners and viewers. If you have a question, post them down in the comments. Make sure that there's a question mark behind that question, because if we have a lot of comments, I usually just search for question marks.
Okay.
We should start. Put a hashtag question into your comment. Then it's easier for us to find them.
Hey,
if you want to support us,
hold on. You know what the other big 3D printing podcast does? They've got hashtag hotmakes. I guess they just search Twitter for that, and then they've got their index of topics they want to talk about.
Okay. Yeah.
I guess tweet at us.
Tweet at us with should we say hashtag the Meltzone, or
just tweet at the Meltzone, I guess.
Tweet at the Meltzone if you're not on Twitter, which I can also totally understand. Just put a hashtag question into your question, and on it's way easier for us to find them on YouTube.
On YouTube, then, yeah. Okay. Man,
if you want to support us, head over to Patreon. No, you can't become a YouTube member here. Become a YouTube member on our main channels.
Can we enable that at 10K subscribers?
It used to be 100K.
Oh.
Apple Podcasts started subscription services, but yes. Oh, and I think Spotify. I don't know. Still need to dig into that.
Okay. Thanks for that outro, Stefan. Thanks all for watching. Thanks, Stefan, for taking the time. And we will see and you will hear us in the next one. Bye.
Bye.